And I'm remembering all the things. Jayu Wang, you just put your name in the Zoom chat. I want you to go to Menti and put it in the Menti chat. I know it's confusing, but I'm just trying to make sure people are on that Menti. Um, yeah, you can also follow along if you join Menti, it'll show up on your like computer screen, and so you don't have to like squint at your computer or rapidly type down everything I'm saying. It'll literally just be on your phone or your computer or whatever you're using. Okay, so today is the day of the big exam. I know for some who are freshmen, it's like your very first exam, and so I'm just going to break down things that seem super simple, but you should all know for sure. Do you know where to show up and at what time? Hopefully you do. It's the same time as regular lecture. It'll be the same time length as regular lecture. You will need a number two pencil. If you don't have that, it's at the NYU bookstore or CVS. The reason why I say number two is because some people use mechanical and it's too damn light. And then our Scantron machine is like, why? Why would you do this to us? And it does not count your answers. And then you get marked off for no apparent reason. Just please use a number two pencil. Do you know how old our Scantron machine is? It's older than me, okay? And they refuse to replace it. Do you know how to use the Scantron? So I will cover that in the next slide real quick before I do. Power off your phones. If it goes off in the middle of the exam, they might look into you. They might be like, yo, are you using your phone? It's a really stupid way to fail because I set alarms, so I am on time for every damn class, but that means that I have like 16 billion alarms going off at all times. Just turn off your damn phone. It's a really stupid reason to fail. Can you use a Scantron? For those who are doing it for the very first time, please use number two. Fill it out like that. Just fill in that little bubble. Make sure that you're using the right number to letter. Double check your Scantron for sure. And also, some important things to know is that intro to Psych ones will probably ask for some kind of identification. You should know your N number by heart. You should be able to bubble that stuff down. You should know your last name on Albert. For example, Andrew Said, if you're out there. Your Albert name is different from your Brightspace name, and it took forever to hunt you down as a student. So just make sure that you have the right name, especially if you have like really ethnic names like Choi. You got to make sure that they have it right and they don't use like your middle name as your last name. Okay? So just please, so we don't lose you as a student, just know what your last name is on Albert. Also know your recitation number. They might ask for that. For my recitation, we're number 14, except for you, Kaylee. Use your regular recitation number. If you are informally switching over, just use your OG number, okay? Or else we'll lose you in the system and then your test score will be lost and nobody likes that. You will also probably get either version A or version B. They have probably two versions of the test if our professor decide to make two. Sometimes he just decides not to, just to make sure that nobody's cheating. And if you put in version B when you actually had version A, they will count all your answers wrong. And that's another stupid reason to fail the test. Moving on. Okay. All my homies vote. This is why I asked you to join Menti. And if you didn't, you can put it at the top. Go to menti.com and use the code, and it should work. All right. We got some people putting some stuff in. I'm gonna give it like 10 more seconds. Going over my practice exam in short answers. Okay. Seems like the majority, in case it's biased towards my recitation students. Y'all just like keep it going. And also, if you don't know what they're talking about, let's see, let me see if I can show you this. I made examples of short answers. They could break into three types. It's basic knowledge questions, comparison, long-winded answer ones. Oh, I guess I have a fourth type too. It's like the worst question in the world, which is create your own. Create an experiment that has 5 steps discussed in class. Name the abstract measure, the way you want to operationalize it, the way you will measure it. Be sure to state your hypothesis if it's observational, experimental, possible confounding variables, and how you will combat bias. I guess my students are asking for this. Or they might be asking for this haphazard semi-good practice test that I made. Let's see. Yeah. All right. Yeah, it's really looking like that. Okay. Strategies on answering short answers. I should have put something else in answering short answers. That's a tongue twister. Okay. Review of the brain. Review of comprehension check. Okay, I'm glad you're all feeling good about the comprehension check. Your feedback should have been emailed to you yesterday. So if you don't have it, like be sure to email me because the feedback I gave on your like short answer, like what are types of bias or what is this example of naturalistic fallacy? The feedback I gave for that should help you on the day of the exam. So y'all check that. Okay, so I'm bored. So I'm just gonna call it now. I'm gonna say go over my practice exam in short answers. This is an open call to anyone who wants to propose the first answer we go over because we have a million questions and like I don't know if we'll cover all of them, considering I also want to go over strategies. Anyone? Anyone? I'm also impatient, so I might just randomly choose my own if nobody speaks up. Sure, answer one. Okay, Kyle, we hear ya. Let's do it. Is that short answer one on the practice test? Because I also have a billion short answers. Is that short answer one on the basic knowledge question, comparison type, long-winded one? Let me see. If Kyle doesn't respond, I'm gonna assume it's on the practice test. Also, if you don't have these links, let me put them down. Okay, practice. Actually, let me put all these links. Like every single link ever, so nobody asks me. I'm getting a bunch of direct messages. I did not make an answer key because I wanted you all to discuss. So that's on you. I think that Amy actually made one. Slay to Amy, by the way. This is the group me that I have for my recitation. I don't care if you join that. This is a collection of our notes. The reason why I'm sharing it is because it also has like the practice test and the short answers. But I made this because our homie does not record his lectures, and that's really sad because I got one guy in Seoul right now and he's like stuck in Seoul, and so just wanted to make a backup system for him. It has like Quizlets. Study guiders, also no, you should be turning in Quizlets now. I changed the instructions. So please do that. Like Ritgra, go off. This is perfect. Love it. Slay for Izzy Kim for turning in her homework. Slay for Genesis for turning in her homework. This is what's due today. Henry, get on that. Yeah. Amy just put in her answers to the practice exam. Go Amy for that. I think I also looked over her answers for something. It was like 6 a.m., so I do not remember, but I edited something of Amy's. Okay, back to it because I am getting distracted. We are answering short answer one on this practice exam. Let's scroll down. This is the really mean one. I don't think he'll be this mean, but at the same time he could be. It would be absolutely valid because he's the teacher and we just get to suffer. So, who wants to tell me the 5 steps to an experiment? 5 if you include iterative process for those who are confused. And if nobody responds, I guess I'll also share my notes. I can pull up my previous lesson notes if nobody's gonna respond and I have to hear myself speak for an hour. Slay, observation, theory, prediction, evidence, and the iterative process. Okay, let me put that in. Go. Theory, prediction, evidence, and then iterative process. Okay, so Should I be boring and use the example he gave in class? I think it had something to do with happiness pill. I could give the other example I gave in class, which I think had to do with operationalizing RIS. Observation. Okay, so I observe. Oh, so I have dyslexia, so don't mind me. That's okay. Fear of roller coasters. Okay, yeah. That works. Let's do that. I'm all for the interactive process. So you all just type in whatever you want to have that. Okay, fear of roller coasters. So you notice observation is all about finding patterns, like looking around in your natural everyday environment and being like, huh, that seems like it's a pattern. Like maybe that's something. Maybe I should make an experiment about that. So maybe I'm at like Six Flags and I'm noticing that a lot of people are like screaming and shitting their pants when they go on really fast roller coasters, and when they come off, they look genuinely traumatized. Um, so I'm like, maybe roller coasters have something to do with the fact that they're scared. Roller coasters and fear. Okay, so that would be basically noting a pattern. Pattern, is that right? I'm gonna say that's right. Your theory. So not only do you have to observe shit, you also have to like hypothesize, think critically, like why? Why do you think it could be that they are so terrified on this roller coaster? Also, know that I'm giving an example right now, but you should be able to do this on your own. Like you should be able to know these 5 theories. You should be able to define these 5 theories, because multiple choice is just going to be about like, do you know this stuff or not? But then short answer is going to be like, can you actually apply it? Like if I said, give me an example of an experiment showing roller coasters and fear, you would have to do this yourself. So I really suggest after this, like you sit down and you challenge yourself to this and make your own experiment. Yeah, but I'm just gonna do this one because everybody has been emailing me about doing the short answer, so I'm just gonna do it and then everyone can shut up. Theory. So in a theory, you want to make a hypothesis. A hypothesis has to be testable. It has to be linking one factor to another factor. It doesn't always have to be causational. It can also be correlational. But hypotheses are always a big part of, sorry about the noise, a big part of theory. So note your hypothesis. It's basically you stating like why you think this is a thing. For example, if roller coasters and fear, I would say, why do you think people are afraid of roller coasters? I would say probably that drop in their stomach, fear of heights, maybe? Fear of heights. Just like how fast paced it is. I would say, okay. When people go on roller coasters, the fear of heights results in fear. So that's basically a claim. So under your theory, you should have a hypothesis, and that hypothesis is explaining that observation, okay? It should be like furthering that observation. It's no longer like, that's casual, like, oh, okay, that's cool. Now you're making a prediction, kind of, and that goes into prediction, which I know it is confusing because he uses a different 5-step process than most of the people who use scientific method. If you look up scientific method, it's going to give you something else. So just look at the picture he gave on day 1 of his lecture and use that. Prediction. Prediction is all about the experimental design. How are you going to quantify a fear of heights? Fear of heights right here would be an example of an operational definition. Yeah, and I can look over your example in just a sec, Kaylee. For people who actually attend this, I will check your short answer if you really want, even though it's probably going to be a lot, but that's fine because I'm so proud of you for putting in the extra effort. Fear will be the abstract concept slash property. Sometimes he uses concept, sometimes he uses property. It's literally the same thing. They're not two separate things. Property. Just know that he interchangeably uses those. Okay, so if fears are abstract property, we're gonna operationally define it into a category that is fear of heights. If I had two operational definitions and I wanted them to be very related to each other, what kind of validity is that called? Anybody know? Anybody? I'll type it in case anyone has hearing aid problems. If I had two operational definitions and I wanted them to relate to each other, what kind of validity is that called? Convergent. Yes. Yes, Grace. Yes, Kathy. Yes, Alice. Yes, Isabella. Yes, Hoyeon Suk. I'm so sorry. And yes, Ritika. I practiced this and I already failed it. I'm so sorry. That would be convergent. Do you know the difference between convergent and construct validity? Can anyone explain construct validity? Anyone? Anyone? If nobody can, okay. Look at Neek. That sounds Greek. That was not a microaggression. Please don't sue me. Contract validity is the relationship between abstract. Yep. So basically, if I wanted to give a really shitty example of construct validity, I would be like, okay, I want to measure fear. And so what I'm gonna do is see how often they smile, I guess. Yeah, you'd be like, what? That has nothing to do with each other. A good example of construct validity. I could add screaming. Yeah, I could definitely add screaming as a operational definition of fear. Let me do that right now. Yeah, Amy. Yeah, go off. Go off, sorry. Or screaming. Or slash and screaming. Where was I? Okay. Yeah, I can absolutely add discriminant validity. Okay, somebody else needs to be answering all these questions. So Amy or Kaylee, you guys are amazing. You guys, please attend to the chat because usually I have only 30 students and I currently have double that. So I am suffering. Okay, so we're going back to this. Abstract concept and operational definition. They have to relate to each other or you don't have any construct validity. The construct has to make sense. If your operational definition, such as fear of heights, doesn't relate to the other operational definition, such as screaming, then if they don't relate to each other, this is a good example of them relating to each other. Screaming and fear of heights is a good example of convergent validity. They're converging on each other. They make sense together. We want to ship them together, like it just makes sense. An example of discriminant validity is it has more to do with measure. So I'm gonna go into that in just a second. Hold your horses, Alan. I see you. So yeah, as a part of prediction, you want to know about your experimental design. How are you going to measure these operational definitions? Like you can't just be like, oh yeah, like I did an experiment and I found fear of heights equals whatever I was trying to prove. You have to quantify it. This goes into empiricism. We got to make sure that this could be replicated anywhere across the world. Like if you wanted to do it in China, like does fear of heights still equal the same thing? Like what is fear? You got to be like very, very explicit so that even a 2-year-old toddler could replicate your experiment. So for fear of heights, we're going to be maybe, what if we said like 10 feet off the ground? Feet off the ground. And then for screaming, screaming is still kind of general, like people scream, sure, that's sound coming out of people's mouths. We could quantify it by saying like the level of fear is the amount of time someone screams, like, or the length someone screams. How about that? Length of screaming. So if someone screams for just like 5 seconds, it's like chill. Someone screams for 20 minutes straight, less chill. But what I really want to emphasize here is that you're basically quantifying it, you're measuring it. This has numbers in it. This is a form of measuring. And so if you see this on the exam, if it has anything to do with numbers, know that it's measured. Measure. Okay. And so we have our observation. Does roller coaster, is there something's going on with roller coasters and fear? Like I just hear a lot of screaming when I'm at amusement parks. Your theory, okay, maybe it's that when people go on roller coasters, they're suddenly like, whoa, I'm terrified of heights. And like they start, yeah, they scream. Those are operational definitions, and then we got measurement. This is your experimental design. Like, how do you want to quantify those operational definitions? The strength of your experiment is only as strong as your measurement tool. Something that I said in class and I also really want to emphasize is that in pre-med or with doctors, they have tools that are just ultra specific and ultra reliable, such as a thermometer or want to check your heartbeat or a blood pressure cuff. They have something that will consistently give them the same result every time. All we have is what we create. So your measurement will determine how strong your experiment is as a whole. So don't forget about this. It's important. Evidence. This is the result. Yeah, so maybe you hang out at the park and you're like, oh wow, okay, I recorded for a whole day. I got a bunch of data. Um, maybe 100 people. Um, yeah, and I recorded their response 10 feet off the ground and the length of screaming. That's the evidence. That makes sense? You'll usually see this as the result part of a research paper. Right. We're getting through it. Okay. Generative process. So, say that, hmm, say that people were just randomly screaming on the ground. People screaming on the ground. People screaming. People screaming. When excited. Excited. And some people just didn't scream on roller coasters. Um, or when I did this experiment and I lifted them 10 feet off the ground, like maybe they were in the spinny ride where you're like in that chair and then they have you by the chains and then you're just spinning around in circles. You're still high off the ground, but nobody's screaming because it's actually really peaceful and you get to see like a really panoramic view. Um, spinny chairs, no screaming. Sorry, I'm making this up as I go, so this is kind of improv right now. This would kind of prove that, hey, wait, I don't know if they're screaming. Like, I don't know if roller coasters are causing fear. If you get like negative results like this, or possible like other confounding variables, you'll have to go through an iterative process. So there's two ways that your experiment could go. It could go positively or negatively. Let's go with negative. Oh man, my hypothesis was proven incorrect. When people go on roller coasters, maybe their fear is not caused by heights or their fear is not done by measurement. Who just annotated? Damn, I didn't even know you could do that. Okay, slay. If it's negative, then I would have to start over. Start from beginning. And you basically have to make another theory, another prediction, go out and gather your evidence, and go through it again. Okay? So that I'm just breaking down the 5 steps first and the way I operationalize and measure it. Does that make sense so far? Iterative process is like when your data like disproves your hypothesis. Like you go through all the effort, you go out and gather your data, and it's like your data is looking you in the face and it's like, you're wrong. Try again. Try again next time. Does that make sense, Max? Yeah. And honestly, this is like the majority of experiments. This is why I quit research. 0 out of 10. I made a whole paper only for my data to not accept me and love me. Do we do it again on the test? Like, you mean this question? These are like sample or like examples. You know, I want you to make your own example. Like, I don't know if we do this exact question again on the test. I don't know, Emily. I'm sorry, but this is just supposed to help you practice and prepare for the test. Really, really, really see if you could convergent and construct. Okay, actually, let me see if I can show you my previous slides or my previous lectures. Did I do my good thing and update? Perception and sensation will not be on this test. Do not listen to anyone who tells you otherwise. What are my sources? I can show you right here. Know that like we did not go over any sensation or perception. So all my homies out there, you're wasting time. Focus on the brain. That was the most recently covered stuff. What I would really recommend focusing on is the brain in the very first day of class, because those are the things that are gonna mess you up, because first day of class was forever ago, and the brain is like barely in your short-term memory. But now I'm going back to show the difference between convergent and construct validity for Rebecca. What's up, Rebecca? Okay, lesson 3. Can y'all still see this? Because I'm moving fast, so I don't know if Zoom is keeping up with me. Okay. Well, nobody answered me, so I'll just hope for the best. We got 3 things. Okay, we got abstract concept, that's number 1. Operational measure, that's number 2. Operational method. Is that right? Measure, operational something. Wait, did I say that wrong? No, okay. And measurement. So what you need to do is operational definition. Thank you. Sorry, I get my words mixed up. It's operational definition. So what you need to know, Rebecca, is that construct has to deal with the first circle and the second circle, abstract concept and operational method. Definition. That's gonna kill me. Abstract concept and operational definition, and it's how they relate to each other. The example I gave when I first did this lecture was, I think it was measuring how long a relationship was going to last, right? That's your abstract concept. And Graham said his operational measure was astrology signs. That doesn't relate to each other. They don't construct well. They're not scientifically proven. They have to relate to each other, essentially, which makes sense because your operational definition is supposed to break the abstract concept down into like little parts. Does that make sense? And then this is convergent validity. Convergent validity is all the different operational definitions broken down into little bits and if they converge with each other. So it's like two different areas. Think about it as abstract concept, operational, definition, and then convergent validity going that way. I like to think of it spatially just because I'm more of a visual person. And if you're more confused about this, go to Natalie, first lecture, and I have all the definitions down here somewhere. You find it because I don't feel like it. Yeah, about the dress. Okay, where was I? Because I'm getting sidetracked with a lot of Q&A. You also have to know if this is observational or experimental. So yeah, I didn't really talk about that as much. How am I going to gather my people? Am I going to be like, okay, I want a bunch of random people to go on a roller coaster, and then a bunch of random people to not go on a roller coaster? Yeah, and then record their response. Or I want a bunch of other people to go on the super high spinny chair thing. Let me look up a picture of this because it's driving me crazy. Spinny chair thing. Like swings. Six Flags. Yeah, this thing. This is my favorite ride. I love this ride. But I imagine people they don't like scream on that, then you know there's something going on, something else going on. So if I wanted it to be experimental, because it's not that ethically dubious, I would gather some people. Maybe let's say 100 people. Two groups. Control and experimental group. And then one control group maybe goes on the spinny ride thing. And then another one goes on, where did it go? Another one goes on roller coasters. That way you have an experimental group. If it was observational, what would this look like? What is the difference between operational and experimental design? Why would someone choose observational over experimental? What if I was testing like depression treatments or cancer drugs? Yeah. Say, man, I just really wanted to see how my CBT treatment would work. But if I wanted it to be experimental, I would have to gather 100 people and give 50 of them depression or something. Now that is ethically dubious. This is already kind of sus. Like if you applied to the IRB with this and you were like, yeah, I want to cause fear in people, they would have you write up like a 10-page paper on how it won't impact them long term. Like even this is very difficult because the IRB is like, yo, we're not about to be like called out for being immoral right now. Like we already went through the whole psychological measure stuff in Guantanamo Bay. Like we don't need any more like tea. Like IRB is going to be on your ass. So observational is for more things that are ethically dubious or things that you just can't like measure naturally. It wouldn't be ethical to like give it to them. Confounding variables. Yeah, observation has way less intervention. I have a great slide on this somewhere. I think it's in lesson 3 maybe. Let's go down. Let's go all the way down. Let's go past this billion slide thing. This is the difference between subject and observer bias. Yeah, here it is. Can y'all see this? Hopefully. So observational is like naturally made. I don't know why I always give the examples of depression and cancer. I need to like change that because it's not only those groups, okay? It can be like anything that is like unethically dubious or whatever. It doesn't have random assignment because you know those people already have it. So you can't just be like, these 5 random people are going to get depression and cancer. they already have it. There's less of an independent variable being measured because you're not giving it to them. Confounding variables are totally big. Like maybe a lot of the depressed people are already really fearful, for example. And it's more correlational. However, we love these observational studies because they support experimental studies. If you have enough proof, like, hey, I saw a lot of correlation between maybe this one specific Reddit group and suicide trends, and you did enough observational studies, you could be like, okay, let me actively get into this. Let me do an experimental study where I have like an independent variable being measured, that kind of thing. So, this calls into question, or this like really brings up the importance of random assignment and random sampling. You should know the difference between those two, and if you don't, go look it up right now, because research design is just such an easy thing to test on. Y'all just really, really know that this is so easy. I could ask you a billion questions on this. In fact, probably most of my practice questions are based on like that kind of stuff. So you should know it. You should definitely know it. And if you don't, go through my slides. Because honestly, I'm pretty illiterate, but if I memorize enough of these graphs that I make myself, like everything turns out all right. Let's go back to whatever we were doing before. Can anyone give me an example of confounding variables or just define confounding variables? Anyone? Let me look at the chat. Yeah, anything that could undermine a certain conclusion drawn to experiments from the experiment's results. Yeah. And I always like examples rather than definitions because I just think that way. Say that this particular roller coaster was right outside a general anxiety clinic. That would be a huge confounding variable because what's going to happen? It's going to be like just by proximity alone, like maybe a lot of people who have general anxiety. Or say this is right outside a preschool and it has no height requirement. Yeah, that means that like maybe a whole bunch of, a factor that may affect the accuracy in your experiment. Absolutely. So this can have anything to do from maybe the way you define your operational definition or the way you measure. You really got to consider if everything is down to a T. It could be a self-selecting population. It could be like your own confirmation bias as a experimenter. Maybe the people on the roller coasters really notice that every time they scream, you get really excited and start scribbling viciously, and they're like, "Ooh, I know you're doing something with screaming." And so they start screaming more often. That would be an example of like subject bias. Yeah, or third variable. What if like I don't know, like you made them drink a shit ton of coffee before they got on the roller coaster, and you also wanted to test if coffee had an effect. Then how do you know what is making them anxious? Is it the coffee or is it the roller coaster? That's an example of a third variable. It really could be anything, and so you just have to be prepared to be able to identify or invent them. You just got to give a good example. I'm just blabbing right now. You don't have to memorize everything that I'm saying, okay? You have to be able to know how to do it yourself. Does that make sense to you guys? Because it might be on the exam. Who knows? But you should know this kind of stuff. And how would you combat that bias? I just talked a lot about bias. I talked about two types. Can anyone name them? Because this should be basic knowledge that all of y'all know. I'm gonna wait it out. I'm doing it. Mm, I love my students. You guys are so good. You're gonna do so great. I'm so proud of you. Um, y'all, these are my students in the chat. I love them so much. You guys are doing great. Subject and observer. Can anyone tell me the difference between a subject and observer? Like if you were to go on a SONA study right now, who would you be? Let me find this because I also have this down somewhere. Yeah, yeah. So remember the comics I made? This is you. This is you soon. By the way, y'all should be doing your SONA because by exam 2, I'm gonna make you guys submit proof that you guys are not putting off SONA. Okay, Max, how could you put how you, sorry, I cannot read. Wow. Also, could you put how you combated these biases in the hypothetical study you did in the short answer? Subject. Yes, you could put how you combated these biases. Yes, in the hypo. Oh, could I put? Sorry, why am I illiterate right now? This is why I'm better in person. I'm like kind of all over the place. Let me see. Okay, so let's say how I combated the. Actually, I want somebody else to answer this because I want to see if you guys can do it. The environment of evolutionary adaptation. Be able to explain and identify the importance. Wait, one thing at a time. First, Mac. I was doing something before this. Remember the difference between subject and observer bias. I'm just going to put this here. Okay? Observer bias is like when you really want your experiment to succeed, and so your expectations lead you to interpret the data in one way or another, biasing your results. Subject bias. You're like, oh, damn, like this guy looks really desperate. You better just do whatever he wants. Can also go the other way. Maybe you're a devious little subject and you're like, I'm gonna mess up this experiment, and you do the exact opposite of what he obviously wants you to do. Subject bias, okay? Subject bias. Ways to combat it. This kind of goes into what Max says. One example is single blind study. The example I gave in class was the Milgram shocking experiment, where he was, yeah, look, go you, Max. You kind of answered your own question. Yeah. Do you want me to give you an example? Because you know the answer already. You just gotta, yeah, look at Julep. Go off Julep. Yeah, y'all got this in check. I can also still give you an example. Milgram shock study. Invited a bunch of subjects in, was like, okay, today you're going to be teaching people. This study is on learning and memory, and you're going to teach them by shocking them every time they get the question wrong. And so the subject, which would be you, watched this other learner like get questions wrong and like increase the shocks every time until the learner was like, please God, no, stop. Oh my God. And the person was still like asked by the observer to be like, hey, no, you still gotta shock them. You still gotta do the thing. And so the subject was just like, okay, damn, and kept shocking the person until the shocked person actually passed out. Anyways, this experiment, plot twist, was actually about obedience and how far someone, the subject, which will be you, is willing to go if someone in a white lab coat like tells you to. This is an example of a single blind study where the subject, you, did not know what the study was actually about. Okay, Kyle, is the observer bias just about interpreting data? It can also be giving reactions while doing the study. Reacting while doing the study. Okay, so this is a good point. If the observer or the experimenter is reacting while doing the study, that is more likely to influence the subject bias because the subject is perceiving that. Okay? Reactions don't really directly influence data. Like the experimenter's reactions don't directly influence data. What influences data is when the subject is like, ooh, I see you, like getting all excited when I tap my hoof 10 times, like I'm gonna do that more often. Does that make sense? It's not about, that doesn't have to do with observer bias. Observer bias is when, for example, a self-fulfilling prophecy, or like you really want this to happen, and so you kind of like think, oh, like obviously it's gonna go that way, or that kind of thing. Think about Rosenthal, yeah. Yeah, that's a great example. The rat maze thing. I have that in the study guide. I'm gonna continue on and get back on track because we are kind of all over the place. How can I combat bias in this experiment? Max asks, how to combat bias. Okay, so we named the two types, subject, observer. If you want to give an example of each, which all of you all should be able to do, example of subject. Subject would be demand characteristics and characteristics. An example of demand characteristics in this roller coaster scenario would be the subject sees the observer write down viciously whenever the subject starts screaming. That makes sense. The observer is doing something to cue the subject in to the experiment. Yes, like, and so that's a demand characteristic. Writing becomes a demand characteristic that causes subject bias. What I would really recommend is writing a bunch of examples of subject and demand characteristics, or asking ChatGPT to use it in a sentence. You really get fluent with this kind of language because it's not like normal English. These are terms. Observer bias. Observer. Dyslexia, sorry. Okay, so observer bias would be, let's see. Let me think. Like, if your prediction, if you really just really wanted it to be like that, and so kind of biased you in any way, let me think. Coasters. Like, even can be on a really tiny level. Like, for example, I start the stopwatch. Start the stopwatch when they just open their mouth. No. And then like maybe like a second after they stop screaming, or like maybe a minute. Yeah, a minute's too crazy. Maybe 2 seconds. Like it can influence it in really crazy ways. Observer bias could be the observer wants their hypothesis to be right. Yeah, that's exactly right. Like maybe they just like squealed slightly and you're like, oop, that's a scream. You guys are scared. That's it. Like it, a lot of behavior is very variable and complex. These should sound like terms you should know. And so there's a lot of ways you can interpret it. Bias of a researcher conducting the study is an equivalent fraudulent behavior, but instead, yeah, a tendency to record more supportive. Yeah. So it could be like selecting the it could be selecting the evidence that is in more support of your hypothesis. It doesn't have to be like you know you're doing something wrong, but you do it anyways, you know? It can influence your behavior in very like casual, subliminal ways. And a way to combat this is what kind of study? It's a double-blind study. For example, yeah, Kaylee, you got it. What am I doing on time? I'm doing okay on time. Yeah, so example of double-blind study is placebo. A placebo study where neither the subject or the researcher knows which pill is which. There's a bunch of issues with placebos. For example, it's pretty obvious if you get like a placebo pill when you're in maybe a psychedelic drug test, and one group is like rolling and the other one has gotten sugar pills, and they're like, okay, we got the placebo. So there's a lot of research going into how to make placebos more like rigorous. For example, this guy in Swiss, Germany and Belgium, made a painful placebo, and it acted more, it like the students or the subjects thought it was actually the medicine more often, and it was more effective as a placebo. There are a lot of different graphs that you should know in here, but I broke down the short answer. I can do it in further detail, but I feel like I covered everything so far. I also want to save some time for breaking down strategies. Okay, so I think I have to skip a bunch of stuff. Oh, this is just recap because there's always that one person that never shows up to any of my recitations, but will show up the day of the exam. Do you know that there's a syllabus that you should be on? It has all the information. Do you know that there is a spreadsheet for the people who don't go to lecture? You can just read the notes. Please go to lecture. Technically, if you break down your tuition, every lecture costs around $250. So every time you skip your lecture, you're flushing down the toilet $250. Unless you're on scholarship, like me, then you're flushing less money down. Know your short answers. This is the practice test I made. These are the possible short answers I made when I found out that the short answers are 40% of your test, which is crazy. Don't tell the professor I thought so, but it's crazy. Do know this, and wonderful Amy made some answers. I think this is where I put down some feedback. No, probably. Oh, yes, it is the one where I put down a bunch of feedback. Go me. Go Amy. Everyone say thank you to Amy in the chat because she's a real goat right now. This is the group me. Yeah. Much love to Amy. This is the group me for that one person in recitation that never shows up but is probably here today. You should just join the group me so you can stay on top of like everything. I don't mind who joins the group me. Anyone can join the group me. My class is on Mondays at 9:30. You can like informally join. I don't really give a shit. This is me to that one random person that never shows up but is here today. You should know me. I'm Professor Nat. I'm applying to clinical neuropsych and I'm doing brain stuff. I love clinical neuropsych, but when I want to break, I do teaching. And I also do tutoring because it's a way to survive in New York. People describe me as Jess from New Girl or Phoebe from Friends. You can join my recitation. It's at 9:30 Mondays and email me before you do, so I just know. Take a screenshot of this, please. Please and thank you. Okay, this is a general review. I don't feel like going over this because it was not chosen. A bunch of materialism and idealism, like the differences between the two. You should know the difference between materialism, idealism, and how dualism kind of like gets into them. This is a meme I made. Yeah, okay, yeah, sure. Here is the slide for julep. Pretty cool name, like an alcoholic beverage. Scroll up. Scroll up, Crystal. I think it should be up there. Yeah, do you know that if you join my recitation, I do swear a lot, and you can DM anybody in that group chat to see how I am as a teacher because I'm kind of crazy. I'm sorry about that. But I make memes. So dualism essentially says that, oh, there is a mind and there's also a body. That's crazy. Materialism is like, no, it's just your body. Like all that your reality is just like physiological neurons firing. And then idealism is like, no, it's just subjective reality. Like, think of the dress, think of optical illusions. Like, bro, we're not perceiving like the same reality. And dualism is like, bro, why can't we have both? Why can't we have both? Oh yeah, I can absolutely upload these slides. I just have not because I am in midterm season, but I made this presentation. I love the brain, but we're not going to go over it because y'all didn't choose it, which is so sad because this is my specialty. I do recommend doing the activity that I had a lot of people that went to my office hours do, which is draw frontal lobe on the front of your hand. It's frontal, parietal, temporal, occipital. Frontal, parietal, temporal, occipital. I would really recommend trying this out. Either front, parietal, because parents are on top of their temperous kids. Even if you have a temper, even if you're speaking crazy language, which is what the temporal lobe does, your parents will always roll over you. And then I wish I had eyes on the back of my head, occipital, eyes. It's in charge of vision. You should also know brainstem. Wow, I can't help myself. I'm just going over brain now. It has the pons, medulla, and midbrain. I don't think you'll have to know this, but you'll have to know that this is the brainstem. And do know that if your brainstem just gets cut off, like, yo, if someone like got you by the brainstem and just ripped it out, you would die. But we know that Phineas Gage got K barbecued through the frontal lobe and he was still okay. Because that's because the stuff up here is more luxurious. We do not have to know the cerebellum, not really. Does anyone have a guide to the functions of each part? Look at the videos on the website that I put in. I made that website for Kaylee and the other person that is informally in my recitation. I'm focusing. I need a TA for this TA class. Someone gets you by the brainstem, you're gonna die. This brainstem, think about it this way. If someone cuts you off by the wrist, the rest of your hand is not going to work, okay? If someone cuts you off by the brainstem, the rest of the brain is not going to work. The brainstem is in charge of breathing, sleeping, heartbeat, all that kind of shit that you just cannot live without. If you get hit by the like frontal lobe, like right here, like you will lose parts of your personality. Like Gage was not Gage after that, and it was kind of like a bummer. But you won't die. You can still use the rest of your hand if you lose like the knuckle part, you know? Does that make sense to y'all? It should make like genuine sense. What cannot be concluded from correlation? Yeah, there you go. Slay. Love when you guys take care of each other. Not gonna go into the brain stuff because you guys didn't choose it, but you should know temporal versus spatial. Good stuff, bad stuff. These are things that are really good temporally and bad spatially. This is good temporally, which means that it's good time-wise. Like at any given time, it will tell you accurately, but it's not good spatially. It can't tell you what's happening deep in your brain, okay? This is me in EG, but we will not talk about it because y'all didn't choose brain. This is me also in an EEG. I really love the brain, but we're not doing that. This is me in an fMRI. I really can't help myself. This is a really cool video. It's me looking at a brain. You can see here that fMRI has to do with, it has to do with, sorry, I'm trying to block a billion ads right now. It's, fMRI is one of those things that is bad temporally and good spatially. Yeah, you're good. No worries, Amy. Just know you don't have to memorize too much about what each one does and blah, blah, blah. But if you do, I have a chart on it. Just go look at the chart. Just know what is good temporally and what is good spatially, okay? This is an example of me in an fMRI. I had to lay there for 3 hours for them to scan every little crevice of my brain. But look, I can see every little crevice of my brain. It's crazy. It's good spatially. But temporally, like if someone was like, tell me what is going on in her brain at this very second. They wouldn't be able to do that because, it's a 3 hour long span brain thing. Whereas if you compare it to EEG, EEG, you only get 19 electrodes. So you're only like looking at 19 little spaces. But these little wires will tell you the exact time, like what is going on. This is what's going on at the exact time right now. My brain is doing that right now. But you only get 19 spots, like 19 electrodes. So like it's really bad, like spatially. Does that make sense? I'm gonna answer that question later because I'm not good at multitasking. More information that we will skip because nobody wants to know about the brain. Should know that if you ever get a PET scan, you will be radioactive. And you will set off radioactive tracers all around New York. For example, if you go and see the Christmas tree being put up, that huge one, you will set off a radioactive tracer alarm that they have for terrorist attacks, and you'll have to bring like a little note that your doctor gives you that said, I was in a PET scan. I'm not a radioactive bomb. I just got a PET scan. Just know that. Chronology, we will also not talk about this because I'm focusing and trying to get to the very end of my slides to talk about short answers. Okay, breaking it down. I have 10 minutes left. Okay, Q in the chat, should I go over question and answers or should I break down short answers? That was not clear. Do you want it to be an open Q&A or do you want me to go through these slides? And don't be shy because this is literally your time to speak up. I am very impatient. Okay. Yeah. Yeah, yeah, yeah. Okay. Oh man. Someone break this tie. What if I gave 5 to 5 minutes? Okay. What you need to know for short answers. I'm going to do this in quick 5 minutes. Short answers. Okay. What if you get this on a test? Say you're sitting down in that Cantor place for theater, but it's not anymore, and your exam is in front of you, and you got your number 2 pencil because you remembered your number 2 pencil, and you're like, damn, how do I answer this kind of vague, open-ended question? Well, what you need to know is the who, what, where, when, why strategy. Let's talk about it. Okay. So the first thing you want to do is underline or like highlight in any way, shape, or form what the question is asking. What are key terms in this question? Okay. Like, is it asking for an example? Is it asking for a definition? Is it asking for a term? It's probably asking for both. And then that should automatically queue up in your mind relevant terms. Okay. So relevant terms that immediately come to mind to me is Charles Darwin, genetic variation, natural selection, and all this extra credit example stuff like tool use, language, mathematics, teaching. You probably remember this from like the very, very first lecture. The reason why I see most people lose points on these short answers is because they don't answer this question in full. Maybe one person will just define evolution, but not give an example. Maybe someone will give other terms like, oh, genetic variation or natural selection is related to evolution, but they won't define it. what I really want from my students is terms, definitions, and examples, okay? And the way that I see them give the fullest answers is by answering this who, what, where, when, why question, okay? So this is just an example of me breaking it down. You should be able to do this by yourself. The key to this is not memorizing, oh, like what exactly was her answer to this, but by using this strategy on the day of the test, which is today, unfortunately. So yeah, use this. This would be the answer. You can see that it combines a lot of the who, what, where, when, why. Evolution, coined by Charles Darwin, explains the traits beneficial to survival and reproduction. Survival and reproduction, those are two as well. Favored by natural selection, and pass over generations, which is the when question. And then it gives an example. Process has led to complex human abilities, which kind of hints at our comparison to apes and other animals. Tool use, language, mathematics, teaching, and other complex behaviors. This is a short answer, okay? You need to be concise. And on the day of the exam, I also want you to underline those key terms that you use, because TAs are looking through about 10 pages of short answers in like a minute, okay? So we're scanning, we're not fully reading. You have that much time to convince us that you know your shit. Underline it so we don't have to be reading through terrible handwriting. By the way, people in my class, some of you had bad handwriting and I couldn't read your answers. And I had to count off for that because I was like, I made 3 calculated guesses about what the word you were trying to say is, and then I gave up. On the day of the exam, they're probably not going to take that time and make 3 calculated guesses about what you're trying to say. They're just going to give you a 0. So please, 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 write as clearly and concisely as possible. I'm begging you. Okay, no, this is just more instruction on that kind of stuff. Yeah, I guess I kind of want to do Q&A right now. I can go back to a slide that does the Q&A this way. You can also put it in the Zoom chat, literally whatever you feel like, and I will use the rest of the time, which is exactly 6 minutes to break down. Yeah, yeah, go Amy. Yeah, honestly, I'm that person too. Like, I love teaching and it helps me study too. So, yeah, go Amy. And a plus. Okay. I feel like people voted for open Q&A and now nobody has questions and I'm confused. Okay. Can you go over reactivity, the special psych problem? Is it just that people react different to the same circumstances? Yeah, the example I gave in my lecture is that I used to work for Karen Adolph's lab in infant research, and literally I had to code videos of infants walking and the last step that they took, if it was left or if it was right. And it seems pretty simple, right? You just code, is it left or is it right? Some people would jump and they would land with both feet. What do you do then? Some people would skip, and so they weren't even landing with their feet. Some people walked backwards. That's variability. Reactivity, sorry, I'm getting it mixed up. That's variability of human behavior. Reactivity is, I would say, like subject bias. Like they see you reacting in one way, and so it influences their behavior. Like, think of Clever Hans. Think of the main characteristics. Can I go over the brain again? I don't know if I have time for that. Can I go over the environment of evolutionary adaptations, explanation, and experience? Okay, like you mean adaptation as a whole? Adaptation is basically you have beneficial and detrimental adaptations. Um, I think in class he gave an example of some bird that started having black feathers because the ground was covered in soot and it survived. That's an example. Slay, go the people in Menti. Um, yeah. The only thing I'm forgetting off the guide is the three broad methods of localization and examples of each. I don't think you'll have to know specifics for localization and globalization. You'll have to know the difference between localization and globalization. If they ask for an example on those two, give the sponge and bicycle example. What are the four basics of natural selection? I have a slide on it, Rebecca. It is in lecture 3. Environment of evolutionary adaptation. Be able to explain it. Okay, so this seems like a really, really, really popular one. So let me just literally go back to my slide on this and I can go through it real quick. So obviously you're going to have variation in a population. We're not all the same. Okay, wow, I keep getting questions. Yeah. No, we don't have to know margin of error. You're good, Julep. When two birds get together and they love each other very much, they go through a process of recombining their genes. Some pre-med guy came up to me and he was like, why don't we take off and recombine our genes? And I never forgot recombination after that. That was traumatizing. But it's really good if you want to memorize it. Sometimes they'll have beneficial, oh, I forgot heritability. You inherit genes from your mother and your father. Maybe you have your father's nose and your mother's hair. Those are heritable traits. It basically means that it's passed down genetically to your children. And sometimes those children will have beneficial adaptations, such as this bird that can now hide in the soot-covered land that we have destroyed. Um, and we also have detrimental adaptations. They're not all good. For example, we really, really, really love sugar because it's a fast form of energy. And now we have an obesity epidemic in America. You do this enough times, variation, recombination, heritability, and you get natural selection, which means that some birds are going to be better at other birds than surviving because they contain the genetics that help them either reproduce or just survive. And that increases their genetic genotype in the gene pool. What is the gene pool? Sorry, I'm like crashing now. The gene pool is essentially this gene selection theory, which I don't think you'll need to know. I think that's really specific. I don't think you'll need to know that actually. I was just going over what he covered in class. I just wanted to make sure I covered everything. But you do this a billion times over and you get evolution. This is a bunch of terms about this. Is environments of adaptation related to what he said about obesity? We have an environment we evolved to live in, adapted to, and now we are in a completely, yeah, I think I'm saying that. And now we're in a completely different environment than what we were adapted to. Our environment changed too fast to adapt. And so we eat more sugar. Yeah, I think I'm saying what you're saying. The sugar thing I gave you an example of. Or you could make the argument for dopamine. For example, dopamine was really important in the learning process for us. Yeah, you go, Amy. Thank you so much for answering people's questions. Everyone reach out to Amy if you have any questions, okay? Because I've got more exams and I gotta write a literature review due tomorrow and I have not. But I will be at the exam today, just for moral luck and good luck and whatever. And you can also go to my recitation. It is on Mondays at 9:30. Peace out to most of you guys. I'm gonna stay for like 3 more seconds because it's past my recitation time. Yeah. You go, you go. Have fun. Bye. Peace out. Actually, everyone email me any remaining questions you have. I think I'm gonna end the Zoom recording. I'm gonna pause this. Stop recording. Peace out, y'all. Yeah, slay. Stop.